Hello, my name is Kerem Bayramoğlu and this is my EE102 project. In this project I made a video recorder and it is using a P-mode Digilant microphone and a simple speaker and basis 3, and I used two concepts here. I used inferred RAM and BRAM as memory units and PWM signals to reform the digitalized data. So here I have this switch, and this switch is write enable switch, so whenever I turn it on, then it is going to start recording, and it's records up to 7 seconds. So let's try it. Ses deneme 1 2 3 ses. So when we are done with recording, as you see, this LED switch lights up, and if I start to pull write enable down, then it's going to start to play the recorded data. So let's try it. So as you can see, there are some noise in the data, and they are due to some errors that we can see in the schematic. Here you can see the memory module of the design. So what I do here is actually, at first I use the inferred RAM, which is the module of RAM you can see here, and I use two address generators for inferred RAM. First one is address generator write, and the second one is address generator read, which you can understand from names that they are used for reading and writing. At first, address generator write works as long as write enable is 1. So when write enable is 1, address generator write starts generating addresses by the clock cycles, and for that addresses, data in is recorded into the RAM. And after the RAM, inferred RAM is full, there is a full mark, full flag, and that full flag is connected to the enable of the BRAM. So after that, as long as write enable is open and inferred RAM is full, block RAM is going to start to record data, and for that BRAM's writing address generator, BRAM write address generator is going to work. And after the process is totally done, there will be another full flag from BRAM, and it's going to show us that the recording process is done. And after write enable is set back to 0, then reading address generators will be working. At first it's going to read values from inferred RAM, and after it's being done, it's going to read values from BRAM. And after reading this data, we will go, this data is going to go to PWM, and PWM is short for pulse width modulation, and the resolution for these data is the resolution for this data is going to determine the duty cycle of the PWM signal. So PWM signal is going to be fed to the JC P-mode connector output, so that when the speaker is connected to there, it's going to generate the analog signal, and we're going to hear the sound. So in order to store more data, I decided to use some compression, a simple compression technique. And in that technique, at first I recorded the initial value, and then when the second value comes, I compare the two values. If the first value is greater than the second value, it means that the value is going to decrease. So I subtracted the initial value from the second value, and I took the 4 bits from that subtraction, and I added one more bit as the most significant bit to that subtraction to understand whether it's going to be added or subtracted after it's going to be extracted from the RAM. And if first one is greater than the second one, then it's going to be positive and I'm going to add, so I set 1 to adding operation, and if it's less, then the second one is going to be subtracted from the first one, and it's going to be the most significant bit is going to be 0. So instead of storing 8-bit of data, I stored only 5-bit of data, and after that I did another process called decompression, and in that decompression I said that if the first value of the most significant bit of the stored value is 1, then the process is going to add the initial value with the other bits of the stored data, and if not, if it's 0, then the data is going to be subtracted from the initial value. Finally, I want to talk about one last detail about my project. So as you can see here, there's this little LED that's lighting up when I'm talking. So it's an error indicator, and as I said, there is data compression, and when the data is compressed, there may be some corruptions when it's being compressed, and that's how I see if there's a corruption. So when the two datas are being subtracted from each other, if the subtraction is not as little as 4 bits, which I am setting as the maximum limit, then this LED lights up. So here I can see that one other reason of the noise may be due to the compression. So thank you, that's all about my project.